Hi everyone, so this is going to be on electrolysis. Before we get started, let's look at the meaning of the different terms. So molten means that it's in the liquid state, so solid, liquid, gas. So molten means liquid state, while aqueous means it's dissolved in water. Now let's look at the solubility of the different forms of the ionic compound NaCl. So it's an ionic compound, so it consists of Na plus and Cl minus ions. When it's in the solid state, so in the solid state, the ions are held in fixed positions, they do not move, and because of this, in the solid state, it does not conduct electricity. However, in the liquid state, the electrostatic forces of attraction are slightly broken, so the ions are separated and the ions are mobile, therefore it's going to be able to conduct electricity. When it's in the aqueous state, which means that water particles have separated the ions, so you have Na plus Cl minus ions, but you also have water, ions produced from water, H plus and OH minus ions. While in the liquid state, you only have the anion and the cation, so Na plus and Cl minus ions. Now, a molten ionic compound or an aqueous ionic compound that conduct electricity, these are called electrolytes. So, for example, sodium chloride molten or sodium chloride aqueous, these are electrolytes. However, substances that do not conduct electricity under any conditions are called non-electrolytes. So a few examples are sugar, which is an organic substance which is made of covalent bond, ethanol as well, C2H5OH. It has covalent bond, sulfur, covalent bond with molecules that do not conduct electricity. Pure water does not contain ions, so it stays undissociated, so it's just H2O molecules. So when you have molecules with covalent bonding, simple covalent structures, it doesn't conduct electricity. So they are non-electrolytes. So electrolysis is actually the use of electricity to break down an ionic compound. The ionic compound can be either in the molten state or it can be in the aqueous state, that is dissolved in water. So we use electricity to break it down. So for example, NaCl liquid, if we pass electricity through it, we can break it down into sodium and chlorine. Now, electrolysis consists of three main components. So you have the electrolyte, which is either going to be in the liquid state or in the aqueous state, and this is going to contain the mobile ions that will conduct electricity. Then you also have the electrodes. So here you have these two are electrodes. Electrodes, they are either made of metals. The metal could be platinum, or it could also be made of graphite, which is another form of carbon. And there are two types of electrodes. There is the cathode and then there's the anode. The anode is positively charged. So the anode is going to be connected to the positive terminal of the battery. The cathode is going to be connected to the negative terminal of the battery, as you can see here. So this is cathode. Cathode is negatively charged. The cathode is negative, therefore it will attract cations. The anode is positive, therefore it will attract anions. So as you can see here, the cations are moving towards the cathode and the anion are moving towards the anode. So negative attracted to positive. So this electrode is connected to the positive terminal of the battery. And then the third component is actually the battery. So the battery is actually providing the source of electrical energy, because we're using electricity to break down an ionic compound. So this gives the electrical energy to break down the electrolyte into its components. So the cations migrate to the cathode and the anions migrate to the anode. Now at the cathode, you're always going to have reduction, and at the anode, you're always going to have oxidation. So we use the little acronym CAO to remember this: cathode reduction, anode oxidation. Now, what is reduction? If you still remember, reduction is the gain of electrons. So at the cathode, the cations will gain electrons. So if we take, for example, the electrolysis of sodium chloride in the molten state, this contains sodium cations and chlorine anions. So the sodium cations will be attracted to the cathode, and at the cathode it will undergo reduction, so it will gain electrons. So I'm allowing it to gain electrons. So this is forming sodium. So Na plus electrons gives sodium. So it's neutralizing. So Na plus is being neutralized by this electron. Now at the anode, the anion are going to get oxidized. And if you remember, oxidation is the loss of electrons. So chloride ions, they are going to lose electrons to form chlorine. And chlorine is formed as chlorine gas here. So because there's 2 Cl, I'm going to add 2 here and 2 electrons. So this is the half equation for the reaction at the cathode, and this is for the reaction at the anode. So if electrons are on the left hand side, so it's being gained, so that's gain of electrons. If electrons are on the right hand side, on the right hand side means it's lost. So there's loss of electrons. This is oxidation. I'm just going to omit the reversible arrow, use a full arrow for these half equations. Now overall, what is happening? So you have sodium cation forming sodium. So one product is sodium and the other product is chlorine. So overall, you have NaCl liquid, which is giving you sodium metal and it's giving you chlorine gas. So you have been able to split this compound into its constituting substances.